Hello everyone. For plotting works, in order to plot maps or plans, we need horizontal distances. We know how to measure the horizontal distance on the plain ground or flat grounds. What if the plan or the ground is what if the ground is uneven, having uneven or some regular slopes, or it might be any sloping ground. So in such cases, how we will measure the horizontal distances? So chaining on uneven or sloping ground is the topic for the session. In that, in order to measure the horizontal distances on the sloping grounds, or in order to chain on the sloping grounds, we have two methods. The first one is direct method, which is otherwise called as method of stepping. You will come to know why exactly it is called as method of steppings. So let us consider this sloping terrain. I need to measure the horizontal distance between A and B. That means horizontal equivalent of the sloping distance, that is AB. I need to measure the distance between AB, that is horizontal distance T. I need this. It might be 1 kilometer or 2 kilometer. How is it possible to measure in such conditions? In such conditions, what we do is we adopt method of steppings. First, the follower holds the zero end of the tape here. Let me consider the tape. The follower holds the tape, zero end of the tape over here. Then the leader holds the other end of the tape and stretch it to some required length. He will stretch some required length for convenient length, and he will transfer this point on the ground, or he will establish the point on the ground. After stretching the tape for required length, he will transport this point on the ground. What he does? He moves like this in forward distance and he transfers the point 1. So likewise, again the follower will come here, again the same procedure repeats, 2. Then follower comes here, again the same procedure repeats, 3. Finally, it will come here. That means we have found out the distance might vary. It based on the ground terrain, the leader might choose any distance, L4. So in such cases, it looks like steps and it is nothing but a method of steppings. So in order to find out D, simply we can sum the different lengths which the leader stretched over the sloping distance. So this is how directly we will measure the horizontal distance between A and B. So another case is we can also find out the horizontal distance in a regular or even sloping grounds by just knowing the sloping distance or difference in elevations. So in such cases, those methods are said to be indirect methods. In indirect method, method 1 is like this. In this, if we have the angle measured, so if this is the sloping ground, I need to have the horizontal distance between A and B. In such cases, we will consider sloping distance L1, L2, and we will consider the slope with horizontal. We will consider the slope. So by knowing the sloping distance and knowing the slope, we can easily calculate the horizontal distance, isn't it? By just taking a triangle over here, you can get it like this. D1 is equal to L1 cos theta 1, D2 is equal to L2 cos theta 2. By just knowing the slope, it is angle measured. This angle is measured by the instrument called clinometer. Okay, I will not discuss about this in detail. Just remember. So by knowing these two, we can easily find out the complete distance between A and B. So this is how we will measure the horizontal distance when the measured angle is at given data. Then we have another method. That is, if the difference in elevation is given. Suppose this is the ground terrain AB. So we will be having the sloping distance L. We need to find out the distance D. If the given data is a difference in elevation, that is this distance, h small h is the difference in elevation, isn't it? That means if I consider any datum, reference datum, so this might be having some elevation, A point might be having some elevation from here. So the difference in elevation is small h. So by knowing this, and if you consider this triangle, it is nothing but a right angle triangle. In such cases, D is nothing but L square root of L square minus H square, considering the Pythagoras theorem. So this is how we can find out the horizontal distance when the difference in elevation is considered. The final method is, it is very much interesting and very important too, examination point of view and gate point of view. That is hypotenusal allowance. Hypotenusal allowance. What is hypotenusal allowance? Okay. Hypotenusal allowance is a method in which correction that is given to the slope is considered. That means, let me explain with this. If this is the sloping terrain, okay, I have a chain. So let me consider, let me fold this tape so that it will we can reduce its length. Yeah, if this is the sloping terrain, so let me do an activity, then I will arise what exactly hypotenuse allowance is. What I do is, I will stretch one complete chain length on this sloping ground. Okay, but hypotenuse allowance, I will write it here. Okay, I will stretch one chain length completely over here. That means if this is B, here this in order to measure the sloping distance, here the arrow has to be placed. But we will consider hypotenuse allowance here. We will consider a slope correction over here. Here what we do is, we will actually place a arrow at some farther distance. So this is A dash and this is E. Somewhere here we will place the arrow. What we did here is, so if I consider the horizontal equivalent of this BA, it will be like this. So I stretched one chain length on the sloping ground and I'll transfer it over here. Isn't it? Somewhere here it will come. isn't it? Somewhere it will come here. So if I transfer this onto the sloping ground, that means the BA's horizontal equivalent is this. Is it not? This is point C. That means if I stretch a length, one chain length on the sloping ground plus this distance will be considered as we have moved forward a one chain length in horizontal, isn't it? From here to here it is one chain. This chain length is transferred over here, that's why this is one chain. So if I transfer this point of the sloping ground, this will be the slope correction. This A dash length is said to be hypotenusal allowance. So along with the one chain length, so based on the slope actually this correction will change. Along with one chain length, if I consider this hypotenusal allowance, then we can say that I have moved forward at one chain length in forward direction. It is simple. So in this case, I need to quantify this A dash, isn't it? So in such cases, let us consider this triangle. So if I consider this triangle, total BA, this BA is written as secant theta into 100 links. So why I am expressing this is I am expressing in links. If I consider secant theta for this triangle BAC, so I am deriving this thing again that is secant theta is equal to hypotenuse. What is hypotenuse over here? Hypotenuse is BA divided by what is this? Adjacent. Adjacent is one chain. One chain contains 100 links. So that's why we are expressing in links over here. So this is simplified and written like this. Okay. Then in order to find out, we know that BA dash is equal to 100 links, isn't it? BA dash is equal to 100 links. So A dash is nothing but BA minus BA dash. So that will be equal to hundred into secant theta minus 1 links. So write it down and you can work out. You will get like this: A dash hypotenuse allowance is equal to 100 into secant theta minus 1 links. But we have different cases. If theta is in radians, on expanding this term secant theta minus 1, we will be having this equation, we will get this equation, that is A dash is equal to 50 theta square links. Remember, so we can use both the formula, and also we have another formula. If theta is in degrees, then A dash can be simplified as expanding this term secant theta minus 1, we can write it like this, that is 1.5 divided by 100 into theta square links. So this is another formula we have, 1.5 divided by 100 into theta square links. So you can use all these three in order to calculate the hypotenuse allowance. Very simple. Just I need the slope. That's it. Theta. So based on the theta, hypotenuse allowance can be calculated. By adding this hypotenuse allowance to the chain length, I can easily consider that I have moved further in a forward direction as in one chain length. It is simple. So let us solve a problem regarding this concept which we discussed right now. So hypotenuse allowance is very much important concept. Yeah, let me consider first problem. Let me read out. The distance between the points measured along a slope is 428 meters. So distance between the points measured, the distance between the points measured along the, it might be AB, measured along the slope is, that is sloping distance is given 428 meters. Find the horizontal distance between these points. Find the horizontal distance D if the first condition, let us consider the first condition, if the angle of slope between the point is the angle of slope, this theta is equal to 8 degree. This is one case. And second case, if the difference in level, if the difference in level, that is h small h, is equal to 62 meters. And final, if the slope is, another condition, that is if the slope is 1 in 4, that means for 4 verticals, sorry, for 4 horizontal, 1 vertical will rise. So this is the slope. This is the three condition which they have given. That is A, this is B, this is C. In order to calculate the horizontal distance considering the first set of data, that is theta is equal to 8 degree, we have the formula D is equal to L cos theta. We know L, that is 488 meters, isn't it? 428 meters, and theta is 8 degree. It's very simple. 423.82 meter is the horizontal distance by considering the first case. This is the horizontal distance. And the second case is difference in elevation, that is h. We know that d is equal to root of L square minus h square. So d is equal to 428 square minus h is 62 square. So on simplifying this, we will get it as like this, 423.48 meters. So this is the horizontal distance when considering the difference in elevation case. See, all the considering in both the cases the horizontal distance remaining same, but some variations are there. Considering the last case, that is the slope is equal to 1 by 4. 1 by 4 means for every 4 horizontal we go, 1 vertical will rise. So for every 4 horizontal, one vertical will get rise. This is the slope. So slope is nothing but tan theta. Tan theta is equal to 1 by 4. So theta is equal to 14 degree. 14 degree 2 minutes is the theta. By knowing theta, as same as the first case, I can easily calculate the horizontal distance like this. D is equal to L cos theta. So L, we know that 428 meters into cos 14 degree 2 minutes. D is equal to, we'll get it like this, 415. D is equal to 415.23. So don't get confused. It is not to be considered as these three horizontal distance to be same. These three are different cases actually. We should not compare one another. Initially I compared these two, but it is not right. Let's not compare. These three are different conditions of the ground he has given. Only the sloping distance remains same over here. So this is how we calculate the horizontal distance by considering this set of data. So let us move on to the next problem regarding hypotenusal allowance. Yes. Let me read out. Find the hypotenuse allowance per chain of 20-meter length. So we need to find out the hypotenuse allowance, A dash, that is slope correction to be find out. That's it. That is, the chain length is 20 meters as given. First condition is find the hypotenuse allowance per chain of 20-meter length if the angle of slope is 10 degree. If the angle of slope is 10 degree. The second condition is if the ground rises by 4 in one chain length. This is the second condition. This is second condition, that is ground rises by 4 meters in one chain line. Slope is given. So this is the second data. So let me work on the first data. Let us work on the first data. If theta is given, you know that I will simply write it as, let me write hypotenusal allowance will be equal to 100 into secant theta minus 1 links, isn't it? This is the formula we have. We know theta, just substitute over here 100 into secant 10 degree minus 1 links. So next we will get 1.54 links. So 1.54 links is the hypotenuse allowance A dash. So but let us mention it in meters. We know that as because they have given 20 meters, we know that it will contain 100 links. 20 meter chain, it contains 100 links. Each link will measure 0.2 meters or 20 centimeters. So in such cases, if I multiply this by 0.2 meter, then 1.54 link will measure 0.31 meter. Though this is the hypotenuse allowance in the first case. So in the second case, it is given like this. I need theta. So slope tan theta is equal to 4 by 1 chain length. One chain length is nothing but 20 meter, as because he is initially mentioning that find the hypotenuse allowance per chain of 20 meter length. So one chain length will be 20 meters, so 4 by 20. So it can be written as 1 by 5, I think, yes, 1 by 5, that is 0.2. So theta will be equal to 11 degree 19 minutes. So hypotenuse allowance, considering the second case, hypotenusal allowance will be equal to 100 secant theta minus 1 links. So substitute theta over here. So we will get 1.987 links. So if I multiply with this, with a link length that is 0.2 meters, or I can simply say that this can be rounded off to 2 links. One link length is 0.2 meters and 2 link length is nothing but 40 centimeter or 0.4 meters. So it will be 0.4 meters. So this is the hypotenuse allowance considered in the second set of data. Yes, so this is regarding chaining on uneven or sloping grounds, and different problems are solved considering this concept. Thank you. See you in the next session. Bye.